Today's session will cover the from two trips method. From two trips is the easiest modeling method in Layout-iQ. It is based on entering the number of trips between two locations. You can follow along building this model using the Project 2 tutorial files that were saved in the Layout-iQ folder at installation. In the introduction video we learned that the software calculates total travel distance in both Euclidean and actual path by multiplying the number of trips between two locations by the distance between the locations in both Euclidean and actual path. Euclidean is the Greek philosopher that hypothesizes that the shortest distance between two locations is a straight line. Therefore the Euclidean travel distance is as the crow flies, whereas actual path travel distance represents the path that products and resources actually take to get from location A to location B. It also calculates the aisle effectiveness, which measures how efficient the layout is at getting products, people, and material from where they are to where they need to be. The reason it is important to reduce travel distance is because it costs time and money to move products, material, and people, and it is considered non-value added. It is time and money that could be spent doing value-added activity. For this tutorial we are going to build a model that was discussed in the introduction video. It is the case of a hospital unit that wanted to change the method of storing supplies on the unit. The hospital was storing supplies in a central location on the unit and they wanted to distribute the supplies closer to the bedside. However, the materials management team that replenishes supplies on the unit didn't want to maintain more than one supply storage location. This model helped the nurses win over the supply management team and justify moving from a central supply model to a distributed supply model. Next, we need to prepare to build the model. We decided to build two versions of the layout, a central supply version and a distributed supply version. To begin, we needed to know how many trips nurses make between a patient room and the supply room and back again. In a conference call with the nurses, we were able to get agreement that the average number of trips from a patient room to a supply room and back again was approximately 10 per 24-hour period. We decided to model a 30-day period, so we used 300 trips in a 30-day period. Projects don't always start with an existing layout, but in this case the layout was available for use in the model. So we started with the existing layout. In reviewing the layout we counted 32 patient rooms and we identified the number of distributed supply locations and where they could be located on the unit. As you can see from the drawing we planned and labeled each location in advance. We validated this plan as we were building the model. We also saved the layout in a WMF file format. We could have used many other graphical file formats including JPG, EMF, BMP, PNG, TIFF, and others. We also included the overall dimensions in both X and Y axis in the file name. The overall distance in both X and Y axis allows the software to extract the distances from the file and accurately calculate travel distance. Once we had developed the modeling plan, obtained the layout file, and verified the number of trips between locations, we were ready to begin modeling. The first step of the model building process is to create a project name and define the data source or type. In this case we will call this project From Two Trips Tutorial and select the From Two Trips data type. The next screen prompts us to create an experiment name. In this case we are going to build the baseline scenario first, which we will name as the central supply scenario. The software defaults to the wizard interface. This wizard will take you through the data forms in the order needed to properly complete the model. Next, we are prompted to create locations. Our location list includes 32 patient rooms and one central supply location. Watch as I create these patient rooms now. Notice that as I create a patient room the software automatically creates a square region, which is a symbol that can be used to select and move objects on the layout. However, if I want to use an actual graphic of the location, then I can create it in the graphics editor. I can create and select objects. I can copy using Ctrl+C and paste using Ctrl+V. I'll copy and paste 2 objects this time. I can move objects 1 pixel at a time with the arrow keys on the keyboard to get alignment. I can also group objects together. Notice that you can set the dimensions of the graphic in the editor. Or if I already have a graphic of the object, then I can assign a graphic to the location. Notice that you can set the dimensions of the graphic in the editor. I can also use the Location Graphic Editor to create, edit, rotate graphics and save them in many different file formats for use in other programs. For this model we are going to use the default region icon to represent locations. Once I have created all locations in the model, I will hit the Next button and the software will open the From 2 Trips table. Notice that this table is created from the location list that you created in the previous step. In this case, we are going to enter the number of trips from each patient room to the supply room S1. That is 300 trips between these locations. Then we are going to enter the number of trips from the supply room back to each patient room. That is 300 return trips. Once the number of trips is entered, we can enter the Next button and the minimum distance screen will appear. The minimum distance table was created to allow designers to create proximity rules during layout creation. Users can create distance rules for location-to-location relationships, and Layout-iQ will illustrate those in the Layout tab. For example, in a manufacturing setting you may want to specify how close an eye washing station needs to be to a paint booth. In this case, we will specify that supplies need to be closer than 50 feet from the bedside. Even though this rule applies to all of the patient rooms, we are only going to set the 50-foot rule for the patient rooms at the ends of the hallways, which will simplify the analysis. That will include patient room 1, patient room 9 and 10, patient room 16 and 17, patient room 23 and 24, and patient room 32. The Next button will take us to the Layout tab. The first thing we are going to do in the Layout tab is import the layout that we prepared for this model. To import the layout, select the Set Background button. Then select the Insert Graphic button. Next, find the graphic file and open it in the window. Next you will select the Set Dimensions button and set the height and width dimensions to the values that are specified in the graphics file. If you select Lock the Aspect Ratio, then you will enter the largest dimension and the other dimension will be automatically calculated. In this case the height and width are equal at 141 feet. When done, select the Set button. Then select the OK button. The layout is now imported and set to calculate travel distance accurately. There is a zoom feature so you can zoom in and out of the layout as needed. You can also move the layout around by right-click, hold and drag the layout to move it. Select the Combined Paths checkbox, which will allow you to edit both directions of flow at the same time. To add locations to the layout, I am going to select the central supply location S1 and place it in the layout. Next I am going to select patient room 1 and place it in the layout. Notice the circle around the central supply location, which is a 50-foot radius. Our design goal was to locate supplies within 50 feet of the bedside. In the current layout, we can see that it is not possible for all locations to be 50 feet from the supply location. In fact, the doorway in patient room 1 is barely inside of the 50-foot radius. Next I am going to drag all of the patient rooms and place them in the layout. Notice that as I add locations to the layout, the software updates the travel distance calculations on the fly. Because patient rooms 9 and 10 are at the end of the hallways, I entered a 50-foot minimum distance between each of them and the central supply room. You can see from the circle that they fall outside of that specification. Notice that the graphic that we created for patient room 32 is still assigned. Let's go back to the Locations tab and change the graphic back to a region. As locations are pulled into the layout, the software automatically creates the Euclidean diagram even if the actual path checkbox is selected. To create an actual path, you must make sure the actual path checkbox is selected. At this point in the tutorial, make sure that the Combined Paths checkbox is not selected. Then left-click on a flowline and drag the flowline down the path that you wanted to travel. When you release the flowline, a node is created. Notice that there are two possible flowlines for every location-to-location relationship. The first flowline represents flow from location 1 to location 2, and the second line is the return trip. You can delete a node by selecting the node and pressing the delete key on the computer's keyboard. If we select the Combined Paths checkbox, then those lines become merged into one flowline, which reduces the merges that have to be performed to complete the actual path diagram. Another way to reduce the amount of work required to create the actual paths is to use path merging to your advantage. For example, looking at patient rooms 1 through 9, if we start merging from the central supply location and complete the merges to each patient room 1 at a time, it will take 63 merges to complete the actual path along that hallway. However, if we start at the end of the hallway and begin merging the flow lines from the end of the hallway, we can complete the merged actual path down that hallway in 19 merges. The point is that editing lines that have been merged is more efficient than editing each flow line one at a time. Next I am going to finish creating the actual path diagram. Notice that as I am building the actual path diagram, the aisle effectiveness is getting smaller. Next I am going to clean up the diagram. The option menu provides several options for users to improve the diagramming. You can edit the thickness of the flowlines. This can provide a more effective visualization of the intensity of flow down pathways and show the congestion more effectively. You can save the layout and diagram in a graphical file format that can be easily added to a Word document or PowerPoint slides. You can resize the location graphics. You can turn off the labels or change the fonts and font sizes. You can delete all nodes and/or all nodes and locations. You can adjust the node size. You can show or hide the diagram. This will allow you to save the graphic with just the layout and no flowlines. Once we are finished manipulating the locations on the layout, we will run the trips by location report. This report outputs all of the information that the model uses to calculate the Euclidean and actual travel distances, and it serves as documentation for the model. The next step in building the model is to create the distributed supply scenario. We will use the experiment menu to create a new scenario. In the experiment menu, select New Experiment. Make sure to save all of the changes that you made to this current experiment. For the experiment name, enter Distributed Supply. Check the Import Data from Existing Experiment option and select Central Supply. With this setting, we won't have to rebuild the model from scratch. Select the Next button to navigate to the location screen. In the preparation for the building the model, we decided to add a supply location that services each hallway, and we pre-planned their locations. So we are going to add 3 new supply locations for a total of 4 in this scenario. We are going to call them S2, S3, and S4. Next, we are going to assign the patient rooms to the new supply location in their hallway. S1 will service patient rooms 1 through 9. S2 will service patient rooms 10 through 16. S3 will service patient rooms 17 through 23. And S4 will service patient rooms 24 through 32. We need to make sure that we also edit the return trips. What happens if we make a mistake? We can always come back and fix it. For the purposes of this demo, I am going to enter a trip value in the wrong cell. We will be able to see it in the Layout tab and then come back to this table to fix it. Now hit the Next button and the navigation will take us to the minimum distance table. Next we need to change the minimum distance specifications. Patient room 1 and patient room 9 are associated with S1. Patient room 10 and patient room 16 are associated with S2. Patient room 17 and patient room 23 are associated with S3. And patient room 24 and patient room 32 are associated with S4. Press the next button to take us to the layout screen. Because S1 is going to move to a new location, the first thing I am going to do is delete the existing nodes. Then I am going to move S1 to its new location. Notice that the only flow lines we have in the layout are along the top hallway. That is because in this distributed supply scenario the supply room S1 is only servicing patient rooms 1 through 9. Notice that I can see the mistake I made in the data table. To fix it, I am going to return to the From 2 Trips tab and delete those trips. We selected this location in our planning step and I would like to validate that decision. I would like to try locating the supplies in the room next door to see if it is a better spot. Notice that the travel distance is greater in the room next door, so I am going to stick with the original plan. I would like to know where the optimal location for supplies is in the hallway. To find the optimal location, I am going to start in the doorway and begin moving the location 1 pixel at a time until I find the spot with the shortest travel distance. Before I begin, I am going to make some adjustments to the drawing so I can work with it more easily. First, I am going to reduce the width of the flow lines. Next, I am going to zoom in so I can see better. Now I can move the location 1 pixel at a time until I find the spot with the shortest travel distance. This is the optimal location. Notice that the optimal location falls in the zone where the two radiuses overlap. If we were able to move the door, then this location would be within 50 feet of all of the patient rooms that it services. Since the hospital is not going to move the doorway, I am going to move the location back to the doorway. But it is still a good idea to know where that optimal location is in case it comes up in conversation with the client. Now I am going to drag the 3 new supply locations into the layout and place them in their locations. Notice the 3 new supply locations all comply with the 50-foot rule. Now I can recreate the actual path flow by merging the flow lines down the aisles. I will start at the end of the hall and work my way in towards the supply location, which will reduce the number of merges that I need to perform to complete the actual flow diagram. Next, I am going to clean up the diagram. Now that the diagram is complete, I am going to run the trips by location report to document this experiment. I am also going to run the compare from 2 trips experiments report and compare distributed supply experiment with the central supply experiment. The compare from 2 trips experiments report lists the results of each experiment and ranks them based on the actual travel distance. Looking at these experiments, we can see that the distributed supply experiment is ranked first with an actual path travel distance of 670,046 feet traveled in a month. The central supply model actual path travel distance is 1,789,369 feet, or approximately 2.67 times farther than the distributed supply model. Nurses in the central supply layout will walk 2,543 miles longer in a year than nurses in the distributed supply model. This is the equivalent distance of nurses walking from Los Angeles, California to Boston, Mass. In excess travel. Using this model, nurses were able to convince the materials management team to support the distributed supply method. That concludes the tutorial of the from 2 trips method. If you have questions, then please do not hesitate to reach out to us at nlee@rapidmodeling.com. Thanks for participating in the tutorial.